Hello friends, this is Dr. Siva Nagaraju, Associate Professor from IARE. Today we are going to discuss Flickr. It is one of the indirect method for demolition of FM waves, and as well as we are going to compare FM and AM systems. Okay, now coming to the topic. So this is a Flickr block diagram. So we are having loop filter, VCO, and product modulator. So S of t is a modulated signal, that is nothing but our FM wave, which is one of the input of this product modulator, and another input is R of t, which is coming from the VCO. So VCO is a voltage controlled oscillator and is controlled by this V of t. And finally, the output of the product modulator is E of t, which is applied to the loop filter. So this is a feedback system, you can see. So the PLL, simply being called as the phase lock loop, is a negative feedback system that consists of three major components. One is a multiplier, loop filter, and VCO. So already discussed, the VCO is a sine wave generator whose frequency depends on the input control voltage. So we assume that initially adjusts the VCO so that when the control voltage is 0, two conditions are satisfied. That is, one is the frequency of the VCO is precisely set at the unmodulated carrier frequency FC. And the second one is the VCO output has a 90 degrees phase shift with respect to the unmodulated carrier frequency FC. So these are the conditions. Now we're taking the input signal, that is FM signal, which is going to apply to the parallel circuit. So S of t, that is our modulated FM signal, which is AC into sine of 2 pi FCT plus pi 1 of t. We have pi 1 of t, which is nothing but 2 pi kf integral 0 to t m of t dt. So kf is sensitivity. Let the VCO output be defined as R of t. Already seen that. We have the product modulator. In the product modulator, we have two inputs. One is S of t and another is R of t. Now, this R of t, which is coming from the VCO. So it can be defined as R of t, which is equal to AV cos of 2 pi FCT plus pi 2 of t, where AV is the amplitude of the VCO output. If the control voltage applied to VCO is V of t, the V of t, which is coming from the loop filter. Okay, then pi 2 of t, which is equal to 2 pi kV integral 0 to t V of t dt. So V of t is coming from the loop filter, where kV is the frequency sensitivity of the VCO measured in hertz per volt. So the output of the multiplier, which is E of t, and E of t, which is equal to S of t into R of t. Already know that S of t and R of t. So substituting equation 1 and equation 2 in equation 3. So we are going to substitute E of t in E of t, that is S of t and R of t. So once again you can see what is S of t and what is R of t. So that is nothing but AC of cos So S of t, which is nothing but AC of sine 2 pi fct plus pi 1 of t. This is S1 of t. And R of t, which is AV cos 2 pi fct plus pi 2 of t. So this we're going to substitute this one. And then to simplify this equation, we're having E of t, which is nothing but AC into AV by 2 sine of 4 pi fct plus pi 1 of t plus pi 2 of t. And another term is plus AC AV by 2 sine of pi 1 minus pi 2. In that E of t, we're having that high frequency term, and another is the low frequency term. This 4 pi fct is a high frequency term, whereas pi 1 of t minus pi 2 of t is a low frequency term. So this high frequency term, which is going to eliminate by using low pass filter. And in that equation 4, having 1 by 2 into AC and AV. So it is taken as Km is a multiple gain, and the high frequency component which is going to eliminate it. So finally we're having a Km AC AV into sine of pi 1 of t minus pi 2 of t. So that is our E of t. So simply you can write pi 1 of t minus pi 2 of t, which is nothing but pi E of t. So what is that one? That is the phase error. So equation 6 is nothing but E of t, which is equal to Km AC into AV sine of pi E of t. Okay. So this phase error pi 1 of t minus pi 2 of t, when both are equal, having that pi E of t is 0. Pi E of t, which is 0. At that situation, the pair is said to be phase lock. Or in a small error also, we can consider pi E of t is approximately equal to 0. Then what happens? Pi 1 of t, which is equal to pi 2 of t. So what is pi 1 of t? So pi 1 of t, again you can see given this one, 2 pi kf integral 0 to t m of t. So here you can write 2 pi integral 0 t m of t dt, and this one is 2 pi kv integral 0 t v of t dt. So once again you can check pi 2 of t is 2 pi kv, 2 pi kv integral 0 t vt. Okay, so 2 pi kv integral 0 t v of t dt. So this 2 pi and this 2 pi is going to cancel and differentiate on both sides. You can get kf m of t, which is equal to kv v of t. So v of t, which is nothing but this one, kf by kv into m of t. That means the output, which is directly proportional to m of t. Okay. This is an indirect method for finding m of t from the modulated FM signal. Okay. Now taking the comparison of FM and AM. So First, we taking the parameter is modulation index. So the modulation index in FM can have any value that is less than 1 or more than 1. Why? We're having two varieties, NBFM, narrowband FM, and wideband FM. Whereas in coming to the AM, the modulation index is always in between 0 and 1. In between 0 and 1. And we take another parameter that is transmitted power. So in FM, no wastage of transmitted power. Whereas in AM, wastage of transmitted power is more. Already know the standard equation. That is, we're sending two sidebands and carrier, so it is more wastage of power. So another is the modulation index determines the number of sidebands in an FM signal. This also coming from NBFM and wideband FM. So wideband FM have infinite sidebands. Theoretically. Okay. Whereas in AM, having only 1-2 sidebands. That is irrespective of the modulation index. That is, we're having 2 sidebands. One is upper sideband and another is a lower sideband. Okay. And taking another one is a bandwidth parameter. So the bandwidth depends on modulation index in FM, whereas in AM, the bandwidth does not depend on modulation index. And another important one is noise immunity. Noise immunity is more in FM, whereas in AM, the AM system is more susceptible to noise and more affected by noise than FM. And the last one is transmission. FM transmission is expensive than AM transmission, whereas in AM is cheaper. AM transmission is cheaper. Okay. Thank you, friends.
Like, share and subscribe. Hit the bell icon for more updates.